Welcome to Math 120, Lecture 4, Section 6.8. Today we're going to be talking about three different items associated with the exponential functions we've been looking at. So to start off with, we're going to be talking about an item called exponential growth. And in order to understand this, I want you to think about an example that would be from a biology class. So think about it as if I was standing in front of you here with a petri dish in my hands, and in that petri dish we have some bacteria. Now, as time goes on, we're going to get more and more bacteria, and that's the idea behind exponential growth. You start with a certain number of bacteria, and then as time goes on, that number of bacteria goes up. So let's go ahead and see what this looks like as a graph. So you'll notice that I have a horizontal axis for t, time, and a vertical axis, which is for n, representing the number of bacteria, or if we were looking at a population problem in general, it would be the population of our sample. So n sub 0 is going to be the initial number of items, initial population, or the initial number of bacteria, and then we're going to go up from there. So what's going to happen here is we're going to have just part of an exponential curve similar to things that we've seen earlier in chapter 6. Now, because this is an exponential curve, we can actually use an exponential function to describe what we're looking at. So n of t, the number of bacteria at any given time t, is going to equal n sub 0, the initial number, times e to the kt, where k is represented by a growth rate. And if you look at your handout, you're going to see that I've given you a description of every single one of those in words. So if you need to see those, again, go ahead and read through those now. So now that we have an idea of what exponential growth is about, let's go ahead and check out a couple of examples using those ideas. In example 1, they're giving us a function, n of t is equal to 1000 e to the 0.01 t. And what they're asking us to do is to just tear apart that function and think about it in terms of all the words that are happening in this world of exponential growth. So in part A, they're asking us for the initial population of bacteria. Well, if you think back to the function that we have over here, we know that n sub 0 is the initial population. Well, n sub 0 is just the number in front of your exponential piece. So we have 1000 then as our initial. So we can write that down. And in this case, because we're talking about bacteria, we might as well go ahead and write that down. So this problem is saying that we have initially 1000 bacteria. Then the next question, part B, is asking us for the growth rate. Well, once again, thinking about our formula over here, K is the growth rate. Well, K is the number in front of the T here. That's 0.01. So 0.01 is our growth rate. Now, notice as you look at this that our growth rate is positive, and that's going to be the case anytime you're looking at a growth problem. But the other thing to be aware of is that frequently when you think about a growth rate, instead of writing it as a decimal, you write it down as a percentage. So in fact, 0.01 is equivalent to 1%. So we have a 1% growth rate. And then finally, in part C, they ask us to calculate the number of bacteria at a particular time. In this one, they're asking us for the number of bacteria after 4 hours. So they're asking us to plug in a t-value of 4. So if they're asking us to plug in a t-value of 4, then instead of n of t, we're going to have n of 4. And that's going to be 1000 e to the 0.01 times t in general, but again, t here is 4. So now it's just a matter of going to your calculator, you type in the right pieces, and you see what happens when you type this in. Now again, you have to be a little bit careful with your parentheses and make sure that this 0.01 and the 4 are both part of your power of the e. So I'll go ahead and write down the answer, and if this is not the answer that you got, then you want to make sure then that you think about all the parentheses that you used, all the exponents that you used, the multiplication symbols and all those kinds of things, and just make sure that you can get the same answer using your calculator. Now, in terms of rounding on this kind of problem, you have to decide then what kind of item you're looking at. In this case, we're talking about bacteria, and it's reasonable then to say, let's go ahead and round to the nearest bacteria, which means we're going to round to the nearest ones place. So if I'm going to round to the nearest bacteria, this is going to be approximately equal to 1041 bacteria. So what that says then is that after 4 hours, we're going to have 1041 bacteria.